Here, we're going to do two limits going to infinity and negative infinity of a function that has a square root in the numerator. So if we want to just get an idea of what's going on, we'll say idea. Look at the biggest term in the numerator and denominator and see what happens. Look at biggest term, see what happens. So if we do that on the one on the left, this we can kind of look at as square root. The 3x to the fourth is bigger than the 5x to the third, so we'd have that. So this is kind of the limit as x goes to infinity of the square root of 3x to the fourth over negative 12x squared. And if we simplify that, that would be square root of 3x squared. I should take another look at the x squared, make sure that it's all fine, over negative 12x squared. And based on this, it looks like the x squareds will cancel, so I should get an answer of square root of 3 over negative 12. But we should verify that that actually happens. In this case, I'll also note that when we did this, we should have been careful what sign should we end up with. Does this match what should happen? Sure. The numerator is going to be positive as x goes to infinity. The denominator is going to be negative. So it makes sense that we got a negative answer. Here we could do the same thing. What happens as x goes to negative infinity? Well, this will be about the limit as x goes to a negative infinity of square root of 3x to the fourth over negative 12x squared, which is still square root of 3x squared over negative 12x squared. But we should check the signs again. In this case, we didn't have to do anything. We see the numerator is positive. It's positive over here. Denominator is still negative as x goes to negative infinity. And that's the case over here as well. Sometimes the signs will mismatch. And that's because when we take the square root, there's really a plus or minus sign up here. So we need to figure out which of those signs we want to use. And you can do that just by checking in our original expression as x goes to positive or negative infinity, is this going to be positive or negative? So in this case, it turns out that we wanted the plus sign on both sides. So we should expect our limits to be the same. So let's go ahead and do that limit. So we'll take the limit as x goes to infinity of 3x to the fourth plus 5x cubed over 9 minus 12x squared. What we want to start by doing is we kind of want to factor inside, and we're going to factor in a weird way. We're going to factor out the largest term. I think while I'll sometimes multiply by 1 over x to that power, I think that in this case, especially when you have the square root stuff going on, it's a little easier to think of it in that factoring way. So we'll factor out an x to the fourth. When we do, we'll be left with a 3 plus 5 over x in the numerator. And then in the denominator, we'll factor out an x squared. We'll have a 9 over x squared minus 12. And then let's go ahead and pull out that x to the fourth from the square root. We'll have x squared. And as we saw, we don't need to add a negative sign or anything because we see that the numerator is already positive, and that's what it's supposed to be. It's supposed to be positive. And in the denominator, we don't really have to do any extra thinking because there's not a square root sign to worry about. A bunch of stuff goes to 0. The x squareds cancel, and we end up with the limit as x goes to infinity of square root of 3 plus 0 over 0 minus 12, which equals, as we expected, square root of 3 over negative 12. if we did the limit as x goes to negative infinity, it would end up being pretty much the exact same thing. So I'm not going to go ahead and do that specifically. What I will do is I'll do one where we need to worry about that negative sign. And that will be the limit as x goes to negative infinity of, we'll just do 3x to the 6th plus 5x cubed over 9 minus 12x cubed. If we do that, it's a similar problem. So we'd go ahead and try factoring out a little bit. In the numerator, I'll factor out a x to the 6th inside the square root. We'll be left with 3 plus 5 over x cubed. And then in the denominator, we'll have x cubed 9 over x cubed minus 12. And when we pull the x to the 6th out of the square root, remember there's really a plus or minus there. We'll have plus or minus square root of x to the 6th, so plus or minus x to the 3rd times the square root of 3 plus 5 over x cubed over x cubed 9 over x cubed minus 12. And now we need to decide, should this be a positive sign or a negative sign? Well, as x goes to negative infinity, the numerator should be positive because it's under a square root initially, so that should be what we want. It should be positive. Square root will just give us the positive answer. So if we're looking as x goes to negative infinity, over here, x cubed will be negative. So we'll have a negative times a positive gives me a negative in the numerator, which means that if I want the numerator to end up being positive, we need to add in an extra negative sign. So once I do this, then we'll have a negative times a really big negative number times a positive square root in the numerator, which is positive as we desired. So we'll have a positive over, this will end up being a, let's see, we'll have minus a negative, so this will end up being positive as well, but that doesn't really matter. We didn't really need to think about that a whole bunch extra. What we will see is that these x cubes cancel out, leaving us with the limit as x goes to negative infinity of just negative square root of 3 plus 5 over x cubed goes to 0, divided by 9 over x cubed goes to 0, minus 12, which will give us negative square root of 3 over negative 12, which is just positive square root of 3 over 12. So there's a few examples of how you can take limits when there is a limits as x goes to infinity or negative infinity if there is a pesky square root involved.